Hello. Okay. Let's review for your Chapter 6 test. These are just examples of types of problems that will be on your test. Number one, let's start with 6 to the 0 power. Anything to the 0 power, just remember, is going to be equal to 1. It goes back to a rule, which is called the quotient rule, and I'm just going to give you an example. If I have x to the fifth divided by x to the fifth, well, if we look at this, we know it's 1 because it should be the same thing over the same thing. But if we go back to where this is defined, this is really x to the fifth minus 5, which is really x to the 0, which is really 1. This is where it's defined from, but to be honest, just remember that 6 to the 0, anything to the 0 is equal to 1. Okay? Number 2, next example. What if I gave you x to the 10th divided by x to the third power? Well, here, same rule applies. You just subtract x to the 10 minus 3, which is 7. Number 3, 4xy all to the third power. Here we have an expression all to the third power, so I would rewrite this as 4 to the third power, x to the third power, y to the third power. And really that's it, but it depends on how we're looking for the solution. And if you have a number to a power, you can simplify this just 4 times 4 times 4. That'll give you 64 x cubed y cubed. Next example, number 4. Here, let's look at a negative exponent. What if I give you 4x squared y to the fifth all to the negative 2 power? That's one negative. That's a mistake. You can rewrite a negative exponent as a positive exponent, then simplify. This will simplify to 1 over parentheses 4x squared y to the fifth, all of that squared. This is how a negative exponent is defined. Well, here, this denominator you can simplify like you simplified over here. So now we'll have 1 over 4 squared, which I can go ahead and write as 16. X to the 2 times 2, which is 4. And then y to the 5 times 2, which is 10. And that would be your final answer. Okay, let's try a few more examples. I believe we're on number 5. If I forget what number we're on, I apologize ahead of time. Number 5, we have x to the negative 3 power over x to the 4 power. Here, what you want to do to simplify this expression, whenever you have a negative exponent, again, you can make it positive by, if it's in the numerator, you move it to the denominator, it becomes positive. If it was in the denominator, you move it to the numerator, it becomes positive. So here, we're going to have 1 over x to the fourth, which that didn't change, x to the third, that came to the bottom, which simplifies to 1 over x to the 7th power. That's it. You'll have several problems that deal with expression simplifying powers. So review that section. Okay. Let's talk about end behavior. If I look at a function, a polynomial function, well, it looks like I'm running out of time now. So I'll move on to the next clip. These are only 5-minute clips, so you have to look at the next one. This will be part 1 for test review.